This problem is from GATE 2021 Mechanical Engineering Set 1. The direct delta function delta t minus t naught for t comma t naught belongs to real number has the following property. So the property here of this direct delta function is given here. The Laplace transform of the direct delta function delta t minus a for a greater than 0, we need to find the Laplace transform of this direct delta function, which is also equal to f of s. So among these four given options, we need to choose the correct answer. Now this direct delta function is defined as delta t minus a. This is equal to 0 when t belongs to, or let me say t is lesser than some value a, and its value is 1 upon epsilon when t belongs to a plus epsilon. Epsilon is a very small value. Let me write it like this. It's limit epsilon tends to 0, and also its value is 0 when t is greater than a plus epsilon. Now you see here that this direct delta function is defined only in the limit a comma, it means it has some value in the limit a comma a plus epsilon. Okay, so moving ahead, now let's define the Laplace transform. So Laplace transform of any function can be written as Lf of t is equal to integral 0 to infinity e to the power of minus st f of t into dt, and that is also called as f of s. That is Laplace transform of a function f of t. Now we need to find the Laplace transform of this direct delta function. So we will write here. Now since this direct delta function is defined in the limit a to a plus epsilon, here you can see its limit epsilon tends to 0, 1 upon epsilon, that is t belongs to a comma a plus epsilon. Okay, so let's write it here. So Laplace transform of direct delta function delta t minus a, this can be written as integral 0 to infinity e to the power of minus st, and instead of f of t we will write the delta function. So delta t minus a into dt. Now let's replace the value of delta function here. So the limit will become a to a plus epsilon, because this delta function will be defined from a to a plus epsilon. So e to the power of minus st, and this is limit epsilon tends to 0, 1 upon epsilon. So this is the value of f of t in a to a plus epsilon into dt. Now let's integrate this function. Since we see here this whole function, it is continuous function, so what we can do, we can take the limit outside. So we can write limit epsilon tends to 0 integral a to a plus epsilon e to the power of minus st, and 1 upon epsilon we can write it here, and dt. Again 1 plus epsilon is a constant value, so we can take it out of the integral and we can write it like this. So limit epsilon tends to 0, 1 upon epsilon, and integral of e to the power of minus st will be e to the power of minus st divided by minus s, because we are integrating with respect to t only, and the lower limit is a and the upper limit is a plus epsilon. Now let's put the upper and lower limit in this equation. So limit epsilon tends to 0, 1 upon epsilon. Now when you substitute the upper limit, you will get e to the power of minus s a plus epsilon minus e to the power of minus as, right? So denominator is a constant, so we can take it outside. So 1 upon minus s, I am taking it outside. Again we can write it as limit epsilon tends to 0, 1 upon negative of epsilon s, this is a constant, and here this you can write, you can take e to the power of minus as common, so we can take e to the power of minus as, so this will become e to the power of minus epsilon s minus 1. Okay. Now see here, we need to solve this limit. So we can write this term as, we can take it outside, so e to the power of minus as divided by s, and let me take minus 1 outside as well, and we can write it as limit epsilon tends to 0 e to the power of minus epsilon s minus 1 divided by epsilon. Now if you substitute the value of epsilon is equal to 0 in this limit, you will get a 0 by 0 form. So this type of indeterminate form can be solved using L'Hopital's rule. So applying L'Hopital's rule here. So what L'Hopital's rule says that if we have a form of 0 by 0 or infinity by infinity, we can differentiate the numerator as well as the denominator simultaneously. Using L'Hopital's rule, we can write, we'll write negative e to the power of minus as upon s to limit epsilon tends to 0. Now if we differentiate this, we will get negative s e to the power of minus epsilon s, and differentiation of minus 1 will become 0, and epsilon, differentiation of epsilon is 1. Now this is not a 0 by 0 form. So if you substitute epsilon is equal to 0, what you will get, this term, this particular term here, this will become what? This will become 1. You can write here negative e to the power of minus as divided by s multiplied by minus s by 1. Now negative and negative multiplied, it will become positive, and this s will get cancelled out. So you can write it as e to the power of minus a. So what we see here is the Laplace transform of the delta function, the direct delta, or sometimes it is also called as impulse function. Delta t minus a will be equal to e to the power of minus as. So this will be our final answer, and let's match this answer with the given options. So if we check the options, we will find option D is our correct choice. If you want to learn more on error function, direct delta function, and their Laplace transform, you can follow the lecture by Professor Adrajit Goswami from Department of Mathematics, IIT Kharagpur. Hopefully I was able to solve your doubt. Have a nice day. Thank you.